Hello viewers, I am Kausalya. Today we are going to solve problem number 6 part 2 under the category Bode plot. And the problem is sketch the Bode plot for the open loop transfer function g of s h of s is given by this expression. So in part 1 we had already solved the values for magnitude plot and phase plot. I will give the link in the description box. Kindly check it, then only it will be easy for you to continue our part 2. So these are our magnitude values for 4 different frequencies. Now we are going to mark these values on a semilog sheet. So this is our semilog sheet. X-axis always stands for frequencies. So here I had started the frequency from a value of 0.1, 1, 10, 100 and it goes on. So x-axis stands for frequency and the unit is radian per second. Y-axis stands for both magnitude as well as phase angle. So in the left hand side I had taken the magnitude. Depending upon the values of the table I had taken the scale here. It is up to you. You can take the scale as per your wish. Right. Now we are going to mark the points here. So for our magnitude value, the first thing is for a corner frequency of 0.1 the magnitude is 40. You see here we have a frequency of 0.1 and the value of magnitude is 40. So this is our first point. Right. And the next thing is for a frequency of 1 the magnitude value is 20. So here lies my value 1 and the magnitude value is 20. So here is my second point 20. Right. Then the third one is for a corner frequency of 4, the magnitude is minus 4. So here, when you look at the graph, you see between 1 and 10 there lies 4. Right. So when you move upwards, you can mark it easily. So 1, 2, 3, 4. This is my 4. So from 4, the magnitude value is minus 4. So when you gradually, this is your 0, right? So here our first point is minus 4. So this is that point. Right. Then the next thing is for a value of 100 magnitude is minus 88. So here lies my 100. So when you move gradually the value is minus 88. So here it is minus 80. So 84 and 88. So this is my final point. Right. So finally we had marked the points on a semilog sheet. Now I am going to use a scale to join these points. Before that we can name the points. You see, let this be A, B and let this be C and let this be D. Right. So first I am joining A and B. Next we have to join B and C. And finally C and D. So this is your final magnitude plot. Now we are going to mark down the respective slopes. For that we have to refer our table. So this is our table. What is the first value of slope contributed by a constant and individual omega term? It is minus 20. So we will mark it on the sheet. So this is my minus 20 slope. So just write minus 20 decibel per decade. So when you look at the second slope, what is the value of change of slope here? It is minus 40. So now we are going to mark this on this semilog. So between B and C, the value is minus 40 decibel per decade. Right. What is the value of change of slope? The next value is minus 60. So just write down the values over there. Between C and D, the value is minus 60 decibel per decade. Right? Finally, we have drawn the magnitude plot for the given problem and this is our magnitude plot. Now we will go to our phase plot. Based upon the angle values, here I had selected the scale range. You see I had started from minus 30 and it is extended up to minus 300 degree. Now we are going to mark each and every point and x-axis the values of frequencies remains the same. right? So the first point here is for a corner frequency of point 0.1, the phase angle is minus 97. Now we are going to mark our first point. The value is for a corner frequency of 0.1. You see here lies 0.1. The phase angle is minus 97. So here is my 90 and the first line is 98. So when you keep a scale and you look over here, so this is my line, right? So here the value is 97. So I am keeping a dot over here. Okay, this is my first point of a phase plot, right? The next thing is 0.5. The angle is minus 123. So minus 123, you see here it is 120, right? So this is the value of 120. So 123 lies here and the value is 0.5. So between 0.1 and 1 lies 0.5. When you move upwards, you see this 5 is your 0.5. So when you come down exactly, just you can mark the point minus 123 over here, right? Then the next thing is for a corner frequency of 1, the phase angle is minus 149. So here lies my, you see here is my 150. So 149 lies just prior to this. And the value of the frequency is 1. So just keep a scale. It will be easy for you to mark the point. For 1, the angle value is here, right? This is my third point. And the next one is for 3, the value is minus 198. So this is 188 here. Between second and third line there lies the point. So always keep the scale. And the value is for 3. The value of the frequency is 3. So over 3, here lies our fourth point and this is my point number 4. And the next thing is, similarly we can draw the remaining things, right? Okay, after plotting the points, you have to join the phase plot using freehand. Now we will join. Right? So finally we had drawn our phase plot, right? So the Bode plot is over here. Now we will find out the values of gain crossover frequency and phase crossover frequency. Gain crossover frequency is nothing but it is the value of frequency when at the point where your magnitude plot crosses your 0 dB line. Okay, as I already said, it is always mandatory to highlight your 0 dB line as well as minus 180 degree line, right? So this is the point exactly where it crosses your 0 dB line. Okay, mark that point. Just keep a scale and accurately look at what frequency does it crosses the 0 dB line. So when you keep the line over here, so it is somewhere around 3.3. Okay, here we are having 3. So it lies here. So the value of our gain crossover frequency is 3.3. So here you can mark that and you can write it at the down. So it is my, 1 point. Here the value of gain crossover frequency is, you see 3.3 because it lies between our 1 and 10 here. So when you look above, you see 1, 2 and after 3 it lies somewhere here. So the exact value of our gain crossover frequency is 3.3. Now we will look at our phase crossover frequency. Again, phase crossover frequency is nothing but it is the frequency where our phase plot crosses minus 180 degree line. So this is our minus 180 degree line, right? You see here I had highlighted that one. So we have to find the point where it crosses exactly. So it crosses exactly over here. Okay, just mark that point little bit brightly. Just keep a scale and measure the value of frequencies. That's it. So here the value of frequency is around 2.5 radians per second. Right. So just keep a scale. It will be very easy for you to do. So here lies my value. So it is around 2.5 radians per second here. So this is my gain crossover frequency and this is my phase crossover frequency. Right. That's all. The problem gets over here. Hope you people understand well. If you have any doubt, comment me. Let me know. I'll try to clear.